Thanks all for coming, and special thanks to Rory who switched our talk slot. Yours doesn't work? Okay, we gotta wait for Jorge to get sound. Otherwise, I can't do this alone. Not today.
Can you turn on the other microphone? Hello? 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 Is it working? Okay, it's good to me.
Do you all hear him? You can. Good.
You guys will have the nice microphone.
That sounds better, yeah.
Okay, thank you. So, hello everyone. I am Jay, and you are Jay as well, right?
With the J team?
And this talk is about build server protocols and new ideas.
Yeah, what new ideas are you talking about?
Well, let's find out.
Okay. So yeah, I'm Justin Kaeser. I work at JetBrains now for not quite 2 years. I have been focusing on SBT integration for IntelliJ. And yeah, I like to complain about build tools because they all suck in some way or another. So I hope to find new ways to make them suck less.
Come on, you promised to be optimistic.
Sorry.
So I'm Jorge. I work at the Scala Center. I'm a DevTools engineer for the last 2.5 years. I co-maintain Scala's incremental compiler, which is also called Sync. I work on build tools and build servers. Our last creation has been Bloop. And I also hack from time to time on ScalaSphere, compiler plugins, and infrastructure in general. I have to admit that my obsession is developer productivity. Some of you already know that, but I just want to emphasize it.
It's more positive than I am.
Yeah. So this is the agenda of the talk. We're going to discuss about the idea. Then we're going to dive into the details of the protocol. And we are going to talk about integrations.
And yeah, so let's talk about a bit how we came together here on this stage. We actually met just 1 year ago here in Krakow on the ScalaSphere conference. Dale of the SBT team introduced us. And yeah, we definitely found out we have common things to talk about.
Yeah, definitely. So now it works, okay.
Okay, microphone troubles.
Fix a sec. So the goals of this talk are basically to explain why BSP solves a real problem. And we want to share our findings. We have a disclaimer around the end of the talk, but so far we want to show you what we've got, essentially. So how BSP came up?
Yeah, so a few months ago, John pretty sort of introduced the Scala tooling working groups, LSP working group and Scala tooling protocol working group, and Jorge pitched the build server protocol, and I found that to be interesting for reasons that we are to elaborate on.
Mm-hmm. So you being the only person that has been working on the SBT integration for IntelliJ, you are probably the best person to judge whether this idea is
not the only
not.
person, but in the last 1.5 to 2 years, mostly, yes.
Mm-hmm.
And yeah, I found it to be fairly complicated to integrate with SBT because there's issues on SBT side and there's issues on IntelliJ side, and I need to be able to map SBT projects to IntelliJ, and
that's not an easy task.
Yeah, I keep running into problems that you might not have when you use SBT from the command line, or if you use IntelliJ without an external build tool.
And coincidentally, those problems have also been found in things like language servers. So I still remember the first day that this idea was pitched in to me by Guillaume Martre, the developer behind the .ti IDE that is currently working with us at the APFL. So he was just complaining about how he didn't want to re-implement IntelliJ SBT's integration within the language server that .ti uses, because he wanted to be able to talk to the build server. So as he didn't want to make a specific build tool integrations, he just wanted to have some kind of build tool protocol that was generic to all the build tools the users used at the end. So,
and I don't want to build specific integration for each and every build tool, like we've just had another build tool announced today, Fury by John Purdy, and just like in this year, Mill has gained some popularity.
Yeah. So by that time, I still remember that there was a lot of fuss about LSP. Olafur was talking a lot about it. He was super enthusiastic. It was a time when he was starting to work on metals and several other tools. So, of course, there was a lot of similarities between these two problems, like providing language server support and providing build tool support. So that's how we eventually ended up with a build server protocol instead of a more custom solution than like a configuration file. So in this case, as I said before, language servers are a primary client of a build tool. They need to have a story for cache invalidation. Language servers are compilers, so of course they have to cache to be performant, and this caching invalidation is changed whenever there is a change in the build tool. But of course, there is no way for the language server to know that the build tool changed a dependency or removed it from the class path. So there needed to be a way for the language server to know that such a situation happened. There is also the case for language servers to want to rely on the build tool to compile projects and get the diagnostics from there, because build tools are eventually the ultimate source of truth.
Even if it's buggy. But we want to faithfully reproduce those bugs in the editors and the IDEs. IntelliJ maybe should also be here, because obviously it's also an editor besides a language server in some sense.
So essentially what you want is to have highlighted source directories within your VI instance. Or
that's right, and I'd like to access an index and all that kind of things.
Yeah. So as I said, build tools are the ultimate source of truth, and only in the JVM community we have 10 different build tools. So we have Pants, we have Bazel, we have Apache Ant, which is a little bit in disuse these days, Gradle, Buck from Facebook, Maven, CBT, Mail, Leiningen, which is more used in the Clojure world, and SVT, of course. All these build tools need to be integrated with, and this is a lot of work.
Too much work. Clickers don't work.
There is so much work that only in these examples we've shown, there is 100 combinations. There is the editors and plus the language servers, and they need to integrate with every build tool if they want to cover every possible use case. And this is only for the case in the present, but this may change in the future. And these are lots of combinations to develop and to maintain.
And to have very specific bugs for. Yeah.
So BSP is an attempt, our personal attempt, to formalize the communication between the build tools and the language server / editors. So I don't know if you're familiar with LSP. I'm sure you are. It's this language server protocol that tries to have a high-level support for languages, no matter what your editor is. And LSP has in its website this quote that says that LSP creates the opportunity to reduce the M times N complexity problem of providing a high level of support for any programming language in any editor, IDE, or client endpoint to a simpler M plus N problem. And this is exactly what BSP does, but for build tools instead of language servers.
Sounds good. So I can integrate with various build tools over a single protocol.
Yes, you can.
Nice.
Does this sound familiar to something?
Well, obviously LSP, but you know, you mentioned a protocol, right? The internet runs on protocols. Protocols are a great thing. Standardization is awesome, except when you want to evolve the protocol, evolve the communication between client and server. So, for instance, we've had attempts to standardize chat protocols. Anyone remember IRC or XMPP? It's fallen a bit into disuse, right?
Yeah.
But I think that's due to the providers of these chat applications, they want to provide a unified experience. They want to quickly add new features. So is the situation with BSP any different?
No,
Don't we want to add new features to build tool integrations?
I think I'm going to stop you right there. I don't think we are in the same situation right here.
Okay.
When we talk about messengers or chat applications, we have essentially two kind of parties involved. We have the developers that develop messengers, and then we have the users. And the users don't care about the developer, what the developers do. So they are better off having a proprietary protocol that they can have control over. But in this case,
maybe I have 12 chat apps on my phone. I'm not sure that's ideal.
Yeah, but in this case, we have many parties involved. We have developers of IDEs and editors. We have developers of build tools. And then we have productivity engineer developers, people that work for companies to make sure that people have fast developer workflows. And that's especially important in big companies. So in this case, you could say that you have people like Sam.
Yeah.
Sam just wants bloody fast and correct compiles. Like, he doesn't care about anything else, right?
Well, he cares about his editor, but I suppose he still wants to use his favorite Emacs and Enzyme stack and still work with his team that prefers IntelliJ.
Right, but ideally for Sam, he doesn't care about what editor or like language server the team members use, right? The only thing he cares about is about having a solution that is extensible and easy to maintain. Otherwise, he just comes to you complaining either, and you don't want that, right?
No, please. So, yeah, these are sort of the list, the diff of the things we want to change between not having a build server protocol and having a build server protocol. So, for instance, we don't want it to be build tool specific. We don't want it to be a one-time effort each time I add an implementation support to IntelliJ. I'd like to share the code between the implementations, and I'd like to have this implementation to be robust and not run into unique errors that are unique to every single build system that I integrate with. And I'd like to maintain it without multiplying myself, because the situation right now is if I spend like at least half of my time on SPT, I can support at most one other build tool.
I think you're hoping for too much, but let's see if we can fulfill your needs.
I do hope so.
So here is when we introduce the BSP protocol. So the BSP protocol is our very personal take of how this formalization would look like. So right now we are going to introduce the technical details of the protocol. We're going to go through them a little bit fast, but just feel free to stop us if you have any questions. And we're going to start with the fundamentals. So the fundamentals is that BSP is, by design, very similar to LSP. We want to draw as much as possible from LSP, the LSP's protocol and the LSP success stories. And we think that LSP has been successful because of a real reason. And we don't know what the real reason is, but we just want to duplicate it and bring it to the build tools space. So these fundamentals are that we have a protocol that is based on JSON RPC, and that we have two different kinds of interactions between the parties involved, the client and the server. We have requests and responses.
Classic.
What?
Classic.
Exactly. And then we have bidirectional notifications. That means that a client can notify a server, and a server can notify a client. And we'll see why that's useful afterwards. The most important thing of the BSP spec that we have right now is that it follows the same format than LSP, and that is client-driven, in the sense that we think about what functionalities are useful in the client's space. So basically, what IntelliJ would like, or what VI would like to have, to provide a nice UX experience, and then we try to implement it or provide that information from the build tools part.
So that means I can support LSP and BSP from the same tool.
Yeah, that means exactly that. If you think about how that would interact, you would say that a client could have a connection open with a language server and with a build server. But the language server would also need to connect to the build server, as we explained before, to get some of the invalidation of the caches or notifications that the build target change. So you could picture it as if it was a triangle. The BSP server, as it is right now, it reuses some of the LSP methods. That's $cancel request to cancel a request that the client makes. It's also window log message, which is pretty obvious. It just logs something to the client. And then text document publish diagnostics, which we'll dive into a little bit later.
Right. I'm excited to hear what all that stuff is about.
Let's wait.
Yeah. So when I want to integrate with a BSP server in IntelliJ, there's a few steps I got to do. So far, there's no standardization for how to connect to a build server or start one. So I'll just start my own. Like, yeah, I'll fire up a loop process or something.
So that's not covered by the spec. It's an implementation detail.
And also how I talk to this process could be standard in, standard out, Unix pipes, TCP, IP, Windows, named pipes, anything.
So what's the first thing you do to connect to the server?
Well, I start up the process, but then once I have a connection over whatever protocol I like, I can send these nice standardized messages like build initialize. So what's in that build initialize? There's just a root URI that would be the project root, right?
Yep.
And capabilities. So I'm guessing I can tell you I, as a client, can deal with these language IDs, so Scala, Java.
Yeah,
is that right?
Absolutely.
Cool. And so once that happens, I hopefully get a response back from the server. Tells me, okay, I'm initialized, and I have these capabilities. I can provide compiles, tests, and a bunch of other things that we might or might not talk about.
We will.
We will, yeah. But so once I got that, I'm clear about how I can talk to the server. So I'll just send the server, yeah, thanks, I'm initialized. And
so so you connect to the server, you are initialized.
I'm ready to talk.
You make a bunch of requests, and then what else?
Well, eventually I'm done with you, right? I have no use for you anymore, so I'll just ask you to shut down. And this is, so why do I have two shutdowns? I have a shutdown to tell you to shut down and another to exit. Is one enough?
Yeah, so the shutdown is basically your request to tell me, okay, be ready to be shut down, and then the exit is the one that just kills me, right, as a process.
I'm sure there's good reasons for that.
Yeah. So when we talk about BSP, one of the primary challenges is to come up with a common notion of what a target is across the build tools and the editors or language servers. So this is a challenge because different build tools have different ways to represent modules or projects. And here we see that we have basically a build tool module that we want to, on the server side, that we want to convert to a build target, which is this common notion we're going to talk about now. And we want that to be understood by the IDE or to be mapped to the IDE at some point.
So in IntelliJ, I have like modules within a project. Would a target correspond to a module then?
Yes, a build target would correspond to a module, but a build tool module doesn't necessarily correspond to a build target. So to put that into context, just imagine Bazel or Pants, two popular build tools, have a one-to-one mapping between their build tool modules and build targets. But in builds like SVT, you don't have this one-to-one mapping because basically the mapping would be between a project and a configuration. So in SVT, you have configurations that represent different kind of like states for a project, and they usually model, compile, and test sources in different ways. So you have a compile configuration that tells you what the compile sources are, and a test configuration that tells you what the test sources are. And for the sake of the protocol, these are two different build targets that you want to compile and test independently.
Okay, I think I can do that.
So we then have workspace build targets. This is the request that the client sends to the server to say, hey, this is the workspace. just give us the targets you can find here. There is a typo here. There should be like the workspace URI, which tells you, hey, like I want the workspace that is exactly in this place.
So those are the targets I can map to modules on my side.
Exactly. And as I said before, these targets have like an IDE, a display name, data, which is a step that we'll dive into a little bit later, and then language IDs, which are the languages that are supported for that concrete build target, or that the build target understands.
Okay, so I'll need a bit more than just targets, because I have a bunch of modules in IntelliJ. What do I do with it? I need to edit sources, right? So can you give me sources?
Yeah.
With it? So I have here dependency sources. Okay, so I just give you a list of targets that I want sources from?
Yeah, and I as a server, what I give you is a target, the target you asked me for, plus the sources I found for that target. And by sources here, we mean a wide array of things. These sources are basically anything that the language server or editor needs to index the project. So it includes as well the source jars or your compilation class path.
So that means I can go to definition of something if I use this code?
Yeah, it means that. And it means as well that you'll get the direct source files and source directories that the module defines. The reason why we include source files there is because there are some build tools that don't understand source directories. They only understand source files, for example, Bazel. And in those cases, we want to support that, so we need to be generic in what we allow dependency sources to represent.
So I need to work around that somehow.
So you've got the dependency sources.
Yeah, I've got the sources. I can index them. I can edit them. Yeah, as you see, I want to compile, right? I have a compiler in IntelliJ that I can use, but when I outsource the work to the build tool, because that's what it does all day anyway. So I do a build target compile request, and I just give it a few target IDs, modules that I want to compile. Right. You do the rest.
And you rely on the build tool to do the right thing, because it knows everything about the Java options, so the Scala C options, and everything it needs to compile something correctly. I, as a server, what I give you is a compile report item. A compile report item is has a build target identifier to know where that compile report item maps to, and then it has information like errors, warnings, time it took, that's optional, and then lines of code. That's optional as well.
That's great, but like I want to do more than send a request, show a spinner, and wait for your compile report. I need to know where the error is so I can tell the user, go here to fix your error.
Right. So in that case, what I send you is that I stream you all the compilation infos that I get. So the compiler, like when you're in your shell, you get just the logs of what the compiler tells you. So what the BSP protocol does is that it represents that as diagnostics. So
that's
if you remember correctly,
are for, yeah.
Yeah, if you remember correctly, at the beginning we were talking about text document publish diagnostics. That's a notification sent by the server to the client that streams all the compilation infos that are received while compilation is still happening.
So they come in one by one, and I can start showing errors before the compile is even done.
Absolutely.
Nice. Okay. Yeah, I can also run tests directly from IntelliJ, but I might not support every test framework out there. We have the same problem as with build tools. Might have to integrate them manually.
Yeah. So we come back at the same problem we said before. We want the build tool to do the right thing.
Yeah. So you only need a build tool integration for the test framework.
Because the build tool already understands what a test fingerprint is or how to detect test files, right?
But maybe we need the test server protocol.
No.
Okay.
So there are other BSP methods as well, but they are not covered in this presentation for the sake of conciseness. So they are present in the protocol, and those are, for instance, build target did change, which is a notification sent by the server to the client to tell the client, hey, like this build target change, try to make sure that all your caches are up to date, etc., right? There are a bunch of things you can do with these notifications. There's also dependency resources, text documents, build targets, and build target text documents, but these are not important.
Okay, that's great, yeah. But like, okay, we have a lot of Scala build tools and I want to support them all, but you know, there's also other languages out there.
Right. I heard this thing about Kotlin.
Kotlin, yeah.
Yeah. I don't like it, but if people want to use it, they can.
Well,
So BSP allows other languages and supports them. So we've got language extensions that are basically pluggable parts of the BSP protocol that the client understands. So if you remember, we had the language IDs when you.
so definitely give you Kotlin.
Yeah. No, don't do that.
Yes, I will.
But you have the build client capabilities, and there you have the languages that the client supports. So those languages that the client gives me also make me decide whether I should include information about specific languages. So if we come back to the previous slide here, you see that we have a field data, and it's an option of JSON. And that JSON has to be detected by the language, and I, as a server, will include information that is language specific. So,
okay,
for instance,
let's have a look at what you give me. Scala extension, Scala organization, compiler version, binary version platform. Sounds good. So I can use all of this to set a Scala SDK in IntelliJ, and then actually know about, yes, you can create Scala files here, and yes, index all these files as Scala files.
Yeah, you can.
Yeah, great.
And then you have another request like build target ScalaSphere options. The Scala, the client can tell me, the server can tell you exactly what concrete compile options are enabled for a project, and can tell you as well the class path and the classes directory. It's going to write
for instance,
everything.
Maybe I could set my inspections based on warning settings or something like that.
Yeah.
Cool.
And then you have things like Scala test classes.
Right. So I already have ability to run tests on your side, but I'd also like to be able to know which classes are actually tests. So you can tell me that.
So is that for the green icon on the cutter?
Yeah,
in
sure.
the editor? Oh, nice.
Like right now we detect this on our side, but why not let me tell you, you can run these tests without ever me knowing, having to implement, yes, this is a test class in this test framework and this is how you run it. I just want to know, yeah, this is a test class, and I want to be able to tell the build server, yes, please run this test.
Sounds great. So this is the end of the technical details of the protocol. Everything is in flux. Nothing is set in stone. And this is, I'm going to reiterate, this is our very personal take of how this formalization could look like. But we have some things on the roadmap. We have things like file watching. So we want the client that knows what file change to tell the server, hey, these are the files that change. I don't want you to hash the sources or the inputs of all your build again. Just use these changes and trust me. And you can save up some build time by doing that. And that's especially important for mono repos and big companies that have lots of million lines of code written in Scala.
What about remote compilation?
Remote compilation is something we may want to support as well.
I definitely want that because our customers like to use underpowered MacBook Airs for Scala development, so they'd prefer to outsource their compilation to a server.
And that makes complete sense. If we want to support that, we may want to reason about how we are going to do it. And there are two options here. We may want to rely on an independent process to synchronize the repos between the workspace in the developer file system and then the one that we will send to a remote, or we may want to pass in diffs like LSP does. And then other things about the roadmap, we are trying to work on, we're going to work on an SBT integration for the BSP, and we are going to provide the tooling necessary to integrate with editors like VI and VS Code, Sublime, and Atom.
So that means once they get their editor running with a build server, they can just as easily switch to IntelliJ.
Yeah.
Without having to update their whole toolchain. Nice.
And then lastly, we want to create a formal proposal for the SDP working group, the Scala Tooling Protocol working group that was initiated by John Preedy, as we said at the beginning of this talk. And that working group will help us ditch all of this away or just refine what we've got and try to find good formalization to support all the build tools that are under discussion right now. I want to say something that I missed at the beginning. It's important to realize that as we have three different parties involved, the IDE editors, the IDE developers, the language server developers, and the productivity engineers, there is a common goal between these three parties. Having integrations with build tools and having integrations with editors is a barrier that everyone has to pass in order to be adopted. So for build tools to be adopted, they need to support editors and the other way around. So it's important that we try to solve this problem so that the people working on editors and the people working on build tools focus on the most important problems, the non-boring stuff. So, is all of this work theoretical, or are you gonna show us something, Justin?
Well, I wasn't going to, but now that you asked me, I have a little thing here. So I'll just open my idea, and Bloop is a tool that supports the build server protocol, right?
Yeah. So Bloop has already been mentioned in this conference several times. It's this like compiled test server, and it's been the test bed for the implementation of the BSP server. So that we wanted to iterate on design decisions and see if we could provide all of this information you've seen here. So yeah, BSP is supported in Bloop.
Great. So if I have a project that is compilable by Bloop, I should also be able to import it?
Sure.
So like some simple toy project?
Let's go for a challenge.
Yeah, like what?
Something bigger.
All right. Like how about Spark? I have that right here.
Sounds good.
Okay. Import as BSP. Next.
Just follow the normal procedure to import a project.
Okay. Session prepared.
Nice.
Window is open. Syncing. I get that syncing feeling. Synced successfully in.
Wait, is that 4 seconds? 4
Make
seconds
it 5.
for Spark?
Make it 5. It's hidden right over here on the display.
It takes 3 minutes for SVT reload.
Here, I'll make this a little smaller. I should make the fonts bigger, but anyway, yeah, maybe you can read it here, 4-point-something seconds. That's nice, and I already have a full project tree here. So I should be able to open up some file, maybe.
Yeah, just go to a source file in core.
Core, where's core? Over here, source, test, no, source, main, Scala, navigate. I'll just open, I don't know, internal accumulator, whatever that is.
Yeah, I just make it fail compilation, see what happens.
No, let's check if the go to source works.
Oh, right.
Doesn't work in this file, but something else here. Going to string, yeah, that works.
Nice.
Boolean, it doesn't use any custom types.
So wait a minute, are you able to support all of the IntelliJ language server functionalities with BSP, with the BSP server?
I don't know, but looks like it.
Cool.
So okay, let's just trigger a full compile on this. See what happens. Queued. Running.
But you already compiled this project before, right?
Yeah, I compiled it before.
So this is just incremental compilation.
Yeah, but 9 seconds, I guess that's just a little longer than it takes for SBT to boot up.
Well, you mean class load?
Class load, yeah, something like that. Yeah.
Okay, cool. Just make it fail now.
Yeah, I'll just add some syntax error in here and save, and oh, it's starting to build all on its own. That's nice.
Oh, can you go to the line over there?
Yeah, let's look here. Here's a list. Okay, expected class or object definition. Yeah, I will expect that.
Oh, that's cool.
Okay, let's fix this error. Oops.
So every time.
Building already.
So let me get this straight. So every time you save, you are sending a compile to the server, and then you get a diagnostics path.
Yeah, and I get the messages while I compile. I can trigger some more serious error that has knock-on effects. Maybe I'll just build info. No. Something that's used by a lot of things. Task state, maybe.
You're gonna get a lot of errors.
Rename this thing, and I get an immediate error output for all the locations, and I can actually navigate to them. Cool.
Nice.
That helps.
You've saved my life, man. I'm gonna use this to develop all my tooling now.
I'm glad.
Thanks.
Another customer one.
So where is it?
So I think that's all I can show you right now. But
Slides.
what?
Slides?
Slides? Slides?
Where are they?
Where are you opening the slides and then?
So
Okay.
this ends our presentation. We want to thank you for listening to us, and thanks also Virtuous Lab for inviting us here. If you want to learn more, well, we are here. Just come talk to us. Help us improve the spec. This is important. It's a collaborative effort. We want everyone to be involved. So just go to ScalaCenter BSP. That's the repository where all the action is happening. And we can just discuss the specifics of your use case as a client.
Or into the IntelliJ Scala GitHub repository. You know, you can actually look at the sources and contribute. Many people apparently don't. And so all this BSP support isn't in the main Scala plugin yet, but I expect to have it as a hidden feature within the next weeks or so. And you can, you know, follow me on Twitter to find out how to enable it.
Follow me too, please.
Yeah, follow him too, definitely. I'm Ibn Verb and he's JVkan.
Yeah.
We have that in the slides. Yeah.
So thank you very much.
Okay.
That's me.
So we're open for questions if you
That's
have
it.
any.
Yeah, we have time
Yeah.
for questions. Any questions there?
Come on, guys.
Yes.
Hello, thank you. So you showed us that, well, doing the Spark thing with BSP works fine. So how does it compare to doing it with the normal flow? Can you show that too?
Oh, sure, but I'm not sure if the time is enough for that. We still have about 3 minutes, so if we're lucky, I'll just...
We can postpone the question until the process is finished, and then you'll see.
Sure, import project, Spark. No.
We have a problem there.
Oh, sorry. Can't use it? There. And something broke in the UI.
So while you do this, we can accept other questions. Is there anyone? Does someone want to ask something?
Is there an overlap between the language server protocol and the build server protocol, and how big is that overlap, if any?
There is a slight overlap between the two. And the overlap is with regards to diagnostics. So we still need to decide whether the diagnostics come from the language server or if they come from the build server. It's a question we don't yet know. ScalaCenter is working on that, and the whole STP and LSP working groups are still trying to figure that out. So
10 seconds.
right now, as we are, as we have the spec, there is no clear overlap like aside of the one I've just mentioned. They are independent servers that try to address independent problems. And yeah, that's basically it.
30 seconds.
What-
Any other questions?
Yeah. What is the maturity of the integrations that already exist, kind of, you know, descending order? How much has been implemented in various places and how mature is it?
So I'd say that IntelliJ is a king with regards to integrations, right?
Yeah, but this integration is a pure happy path, no error handling, no test integration. We call it conference-driven development.
Yeah, it's a prototype. But in this case, so I would say that the most popular build tools, Maven, Gradle, and SBT are the ones that have excellent support. But there are many, many other build tools that are aside of that equation, and they are not well supported, like, for instance, Bazel. Bazel has a specific IntelliJ plugin that doesn't work really well and asks the user to specify exactly what the source directories are. And of course, that doesn't scale. So what we see here is an opportunity to create to continue to develop this integration, make it more robust, and hopefully someday provide more build tools and make the barrier to adoption way lower to the one there is right now. I'm a big proponent of bazel and pants, so everything that can help that is good.
Okay, we're at 2 minutes almost.
Yeah, Alexa?
You said that it's independent from LSP, right? So there is probably little overlap. Still, why not to make it an extension to LSP, which is kind of a standard thing already? There are some extensions to the LSP protocol. So why not to reuse some basic things like initialization, log messages, diagnostics, and add what's missing?
So the idea here is that BSP solves is similar in the mission statement, but it solves a different problem. So aggregating all the solutions to that problem in LSP doesn't seem the right solution, at least in my opinion. I think we're better off with an independent protocol that independent parties can contribute to. And build tools are beasts. They are complex pieces of software that, and I would expect this protocol to grow quite big. So I'm pretty sure that it wouldn't be feasible if we would have implemented all this within the language server spec, which is only trying to solve the problem of having excellent language support for different editors and IDs.
I see John Pretty just came in. John, did you know you have IntelliJ support for your build tool that you announced today?
Sorry.
Did you know you have IntelliJ support for the build tool you announced this morning?
Was that between me walking from up there background downhill?
Yeah, probably, yeah. You missed it, sorry.
Sorry.
No problem.
Any other question?
I don't think we have much more time.
Gabriele has one. Okay.
Okay.
We'll make an exception.
Sure. It's actually a very super small question. You mentioned that initialization is implementation detail, right? So I guess if you want to add another build server implementation to IntelliJ, for instance, you need to bake that in. And the question is how specific is the code that runs is that particularly complicated to run the build server in your experience so far? Right.
No, it's not very...
We have the same problem with LSP servers, essentially.
So for the case of Loop, it wasn't very complicated. It's just running a process with a few parameters and initializing a socket connection.
Yeah.
It will need a little work for Windows and TCP, but that's pretty straightforward, I think.
By initialization, you meant firing up the server. Yeah, so Loop supports just it's a CLI tool, so you just do Loop BSP, and then you pass in the socket file you want to communicate through, if you're in Linux, or BSD, or Unix, and then you pass in the name pipe if you are in Windows, and it also supports TCP. So if you want to do some kind of remote compilation or send that to a server, you can also do it. But yeah, as you said, like I would expect that to be an implementation detail, and I wouldn't expect that to be really difficult. You could do the same for SBT, BSP, and then you would have like an open connection to BSP, and you could potentially do the same with other tools like PANTS.
Maybe we can eventually agree on some more generic thing where we just give a URL, here's the server, connect to it.
Yeah.
Okay.
Yeah.
Thank you, guys.